Hello viewers, I am Maitli. Today we are going to see 11 Cbse Max Complex Numbers and Quadratic Equation Exercise 5.26 sum. Let's see the question. Convert complex numbers to polar form. We are going to convert the complex number to the polar form. Here the given complex number here is -3. If there is no imaginary, we know that for the complex number we have a real part and an imaginary part. Here we don't have a imaginary part. For that we are going to take, let z is equal to, here it is given as -3, we can add plus 0i. If I add plus 0i, it becomes a complex number, and as there is no value of imaginary part, we are just multiplying it with 0. So 0 into I will become 0. So I have not changed the question, it's the same. Now we know that the complex number polar form will be r cos theta plus ir sin theta. I need to change to this form. For that we need to find the r and the theta value. So I'm just going to substitute the complex number of -3 plus 0i is equal to r cos theta plus ir sin theta. The real part will be equal to the real part over here. Same way the imaginary part to the imaginary part. I am going to equate this separately. If I equate, I get r cos theta equal to -3 and ir sin theta equal to 0i. Here I gets cancelled and we know that r sin theta will be equal to 0. I am going to take this equation 1 and this to be the equation 2. I am going to square the equation 1 and 2 and I am going to add it. Because to find r, I don't want this sin theta and cos theta. To eliminate it, now see how I am going to eliminate. Squaring equation 1 and 2. Squaring and adding, you can write equation 1 and 2. If I square, I get r square cos square theta plus r square sin square theta equal to, here if I square -3 the whole square, 0 square. If I take r square common outside, I get cos square theta plus sin square theta equal to 3 square will become 9, minus will become plus. So 0 square no need of writing because it becomes 0. 0 with addition of any number we will have the same number. So no need to write 0. Here this becomes 1 and r square equal to 9. R will be equal to 3. As it is plus or minus, we need to take only plus. So I am writing just r is equal to 3. Now we found r, we need to find the theta value. For that we know the formula tan theta equal to modulus b by a. I want tan theta, but here there is no tan theta. For that I am going to divide second equation by the first equation, because here it becomes sin by cos, so that we can find sin by, we can write sin by cos as tan theta. So divide second equation to the first one. So now this becomes r sin theta is the second equation. By the first equation is r cos theta. Here 0 by 3. Now 0 by -3 in modulus. R get cancelled. Sin theta by cos theta will become tan theta equal to 0, because 0 by any number will become 0. We know that tan 0 is 0 degree. So instead of 0 we can write tan 0. We know that now theta value to be 0. We can't substitute this theta value over there. This is not the theta. There we need to write the argument z, the argument of the given complex number we need to write. But here we have found theta value to be 0 and we need to substitute, we need to find the quadrant where the given complex number lies. So let us check the quadrant. The given question is -3 plus 0i, that is minus plus. You need to take this to be the x-axis and this to be in the y-axis. Here minus plus will come in here minus x-axis and plus comes in second quadrant. Now as the real part is negative, we need to write this to show them how we are finding the quadrant. real part is negative and the imaginary part is positive. We have taken this 0. I always take, if there is a 0 you are going to add it, always take it to be positive. It lies in the second quadrant. We know that in the second quadrant it is pi minus theta. For second quadrant it is pi minus 2 theta. So we can write argument z is equal to pi minus theta. Here theta value we found it to be 0. So it becomes pi. Argument z is pi. Pi is the value of theta. We are going to substitute in it. We know that z is equal to minus 3, which is equal to r cos theta plus ir sin theta. If we take r common outside, we get cos theta plus I sin theta. R value we found to be 3. So 3 into cos theta value, here we need to take the argument z, that is pi plus I sin pi. This is the required polar form, is the required polar form of minus 3. So this is the required polar form. We have found the polar form. That's all with the sum. Thank you.